Alright everybody, in Algebra, thank you for stumbling upon this video and choosing to watch it. We're going to be covering 1.7a, goes with that note sheet. So please make sure that you have that in front of you as we go through this, so that you can fill your notes in and you're ready for the practice problems and the homework. Alright, so first we start with some vocabulary. We have the coordinate plane, and a coordinate plane is a grid containing the horizontal x-axis and the vertical y-axis. When naming points on our coordinate plane, we have an ordered pair. We're always going to write the x value of the point before we write the y number. And this basically tells us where on the coordinate plane we want to go. Okay, so what we're going to do here is we're going to label the axes, quadrants, where we have positive and negative coordinates. So remember, our x values are going to come first and our y values will come second. So let's start with the x-axis. Remember, that's horizontal. So right here, I'm drawing over the x-axis. And the x-axis works kind of like a typical number line. These over here on the left are going to be negative x values. And over here on the right, we have positive x values. Which means that on the left side of this grid, our x values will always be negative. And on the right side, they'll always be positive. The y-coordinates are going up and down. And it goes kind of like how you would expect it to. Positive y values are further up, negative y values are further down, which means that on the top half of the grid, we have positive y values, and on the negative half, we have negative values. Now, there are 4 divisions on the graph, as you can see. Ones where both are positive, ones where both are negative, and 2 of them where one is positive and one is negative. These are called quadrants, and we label them according to Roman numerals. We always start in the upper right-hand corner, and this is quadrant 1. We then sort of go around counterclockwise. So this one here is 2, this one here is 3, and this one here is 4. So we go around the circle like that. So that is quite a bit about this coordinate coordinate plane. So now that we've looked a little bit at the plane itself, let's talk about what we can do with it. One thing we can do, working with functions that we've talked about last week, is we can make a graph of a function. So here's our first example. Let's say we wanted to graph this function here, y equals 1/3 x plus 1, with this domain. Well, we're going to start this out just like problems from last week. We're going to put our domain in for x. So 0, 3, 6, 9, 12. And then we're going to put our x values in for x and see what y values we get. So for this first one, our function is y equals 1/3 x plus 1. So we're going to have 1/3 0 plus 1. 1/3 of 0 is 0, so that answer is 1. So that's our y value. Next, we would have 1/3 times 3 plus 1. 1/3 times 3 is 1, plus 1 is 2. And, we basically keep going like this. So 1, that would be 2 plus 1, 3. And, you keep plugging these numbers in. I would recommend you do it. I'll just write down what it would look like for each of these. And these end up being 4 and 5. So what we can do is, now you'll probably notice that we have an x and a y value for each of these. Like for this first input-output set, we have an x value of 0 and a y value of -1. This is telling us that one of the points we're going to put down is this point, 0, 1. 0 is the x value, 1 is the y value. So I go over to the graph, and an x value of 0 is right on the axis, and a y value of 1 is 1 up from there. So this is my point 0, 1. Now I'm going to make the other points too. We have the point 3, 2. We have the point 6, 3. We have the point 9, 4. And we have the point 12, 5. And that's it. We've graphed the function. Notice that the points are going in a straight line. Doesn't always happen, but it did here. All right, next example. Graph this function with domain 1, 2, 3, 4, and 5. All right, so domain first, 1, 2, 3, 4, and 5. And then we plug them into the function, which is y equals 2x plus 1. So 2 times 1 plus 1, that's 2 plus 1, which is 3. 2 times 2 plus 1, that's 5. 2 times 3 plus 1, that's 7. 2 times 4 plus 1, that's 9. And 2 times 5 plus 1, that's 11. We have our points to graph now. First one is the point 1, 3. So there's 1, 3 on the graph. Next one is 2, 5, 3, 7, 4, 9, and 5, 11. And there we have that example. It's already done. So, graphing these is not that bad. It's sort of combining what we did yesterday with what we did today. All right, real-life example. So, we often use variables other than x and y to represent real quantities. The variable that appears first in a table goes on the x-axis and is independent. This is very important. So you're going to encounter two variables. The first one is usually going to be considered the x value, the x variable. And the second one will be the dependent variable. It will go on the y-axis. We always want to keep this consistent. All right, so example 3. The average ticket price, P, of a Green Bay Packer football game is given based on the time T for each year since 2010. Year 0 corresponds to 2010, year 1 corresponds to 2011, and so on. And here we have much information given to us. So the first thing we need to do is label the graph and scale. Well, remember, the first variable you see is going to be on the x-axis, and the second variable you see is going to be on the y-axis. So, years since 2010, we have 1, 2, 3, and 4. So we can scale this pretty nicely down here. I would say go every 4 spaces or so. So this is 1, 2, 3, and 4. What are we measuring down here? That would be years since 2010. On the other side, we have average ticket prices notice that our lowest value for average ticket cost is $190. So one thing we can do is we can skip a bunch of values, and we're going to do that. So just make a little jagged line here to indicate the graph is kind of crumpled up, and we're starting, let's say we started about $180. Right there. Okay, so $180, and we're just going to say that every 2 boxes is 10. So this up here would be 200, 220, 240, and we could keep going, but we don't really need to. All right, so we've labeled the axes. We have scaled the axes. We know what the values all stand for. Now what we have to do is plot our points. So our first one is 190. So that's right there. Our second one is 235. That's going to be right there. Our third one is 218. 218, remember, is going to be pretty close to 220, so kind of right there. And lastly, we have 4, 192. And 4, 192 is right around there. All right, so we have our points. What year was the highest? Well, we can see clearly that the best year for ticket prices was 2 years since 2010, so that's 2012. Why might that be? Well, probably because the Packers were great that year. That was the year that they were doing really well. It was a winning season. They had a Super Bowl that year or around there, so that probably influenced them doing really well and getting a lot of money. And being able to look at graphs and determine things like that or guess on things like that is a really important skill. All right, so before you move on to the homework, we have in class practice, gauge how well you're doing with the material and determine whether you want to do red, yellow, or green practice problems. Your homework is found here, but also found on your note sheets. So, just make sure that you complete some of the practice problems and then make sure that you bring your completed homework to class tomorrow. Thanks for watching. Hope you learned a lot.